Welcome back. Today we're talking about SQL Functionality from my Database 2022 course. Let's go ahead and take a look at this. When we're talking about SQL and functions and methods, we're looking at the idea that we want to manipulate the data on that. Now, I use the term function method almost interchangeably because, again, I grew up with a Java background, so that's where we're coming for with this. You're going to often see these you're often going to see these just referred to as functions, but methods also work because you're talking about an action that's being performed. These all, however, are in the mathematical term functions because they return values. So just as an FYI, that's what that term on that is referencing. These are commands we can use to work with data inside SQL. They can operate on text, numbers, and even more. We'll talk a look at these. These are specifically looking at functions that work within the text and the numeric side of things. We'll look at functions that work with dates another time. The basic structure of all the SQL functions is going to be the command name. Now, there's not going to be usually very many that have multiple things, so we don't use snake case with underscores to take care of that, but command name followed by parameters separated by commas. And in SQL land, a lot of the parameters are optional, so you can don't have to have them. You can just add them for more detail, like an overload method in Java. But you have the idea that you have the more parameters you're adding, the more detail you're adding to the function, the more functionality that you're actually adding to the function. So just as an FYI, that's why that's there. And these work with either fields themselves or actual values you can actually hard code or spell out or retrieve from other data sources. So just as an FYI, when we're talking about passing information to the function, it can be hard coded information or information retrieved from a query itself. So just as an FYI, that's where that's going for. The first place we're taking a look at where SQL functions exist is inside the select clause. The select clause is where I put a function because I want to change how I'm showing the data or manipulating the part of the data I'm actually displaying on the screen, or if I'm using this as a subquery, how I'm going to give part of that data out so I can retrieve it later on. And so that's what I'm working with when I put it inside the select query. Now, when we're talking about these select query based functions, I require the use of the as command on every single statement. I require the use of the as command on every single line inside the select clause where you have a function or anything that's not simply just a name of a field, because we want to obfuscate and or hide that logic. Now, there's three reasons why I expect you to use the as command to hide that logic or to obfuscate the information. The first part is that makes it so much easier to read. If you have a giant queries thing as the metadata on there, it's like, oh, what's this blah, 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 blah. Yeah, no, I don't want to read blah, 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 blah for the actual query title. I want to read, oh, this is the name of the thing. This is the car address. This is the dealership, whatever. All the information I want to retrieve out of that is what I want to have as the metadata or the title of that column. Humans making it easy to read is the biggest reason when we're writing code is we're doing things to make it easier for us as people. That's why we do that. The second reason we want to do is for security. That metadata information that's up there at the top, that's what comes back out when you're exposing this code. Say, for example, you're going to give this query to another application or going to a subquery, something like that. And by exposing that metadata, the column header information, which is what the metadata is, you are giving access to the people using that data information that they probably don't need access to and possibly could be used in nefarious purposes. And we do not want to do that. We already have enough issues with computing security as it is. And so by exposing that data inappropriately, you could cause more problems. One of the reasons we do that is because of the fact that the query information, what you put inside that lovely metadata, what goes into that thing, could potentially include information like login information, private information, data that you don't want to actually share beyond the actual scope of what is being displayed. And so to have increased security, we want to as that away as well. So it's easy to read for humans, number one reason. Number two reason, take care of security. And number three, ease of access for complex queries. If I'm doing a big, huge nested set of queries or subqueries on that, then what I need to do is when I use a query and I have to actually reference that, I'd have to, when I'm trying to retrieve that information from whatever column I'm looking for, I have to get I want to do the name of the table dot the column name I'm working for. And if I have this huge, ginormous pile of blah, 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 that's going to be hard to actually write a query on. And again, going back to rule number one, easier to read and easier for humans, we want to make that ease of access for humans, again, on complex queries. And so I give a simple name that I can easily access when I'm referencing that interior column of information. So we want to make sure that we always use the as command on every single function inside a query. Keep that in mind again. Next place we're looking at, this is inside the where clause. And we're working in the where clause, again, we're always looking at that to take down the number of rows we display on our results, because I want to take that and I want to restrict the values because the where clause squishes those down. When we're working with this, we always want to keep in mind that when we're working with the idea of a logical comparison, that the and requires both sides of an equation to be true, the or only needs one, and not negates results. And so when we're working with functions inside the where clause, De Morgan's law also still applies, and the parens are still kind of a big deal. I know it's weird. So when putting functions in the where clause, keep those pieces in mind because the logic you're doing with that will still affect the other parts of that clause. Now let's take a look at some of the string functions. So string functions are how I can manipulate or extract information from text-based values. Now, when we're working with a database, you want to make sure you remember that when we're talking about databases, the indices of a string start at 1. I know this is different if you're coming from this from a Java side, a C++ side, a Swift side, hey, just about every programming language. But when we're talking about database land, the indices start at 1. So keep that in your brain. Remember that we're working with that. When we're looking at information about a string, we've got a couple methods like that. We have the length command and the inster command. So length tells us what? Oh, that's right, how big the string is. Weird. And inster is where in the string is the supplied phrase. So those are the two information-based ones. We have padding, which isn't very used as much anymore, to either LPAD or RPAD for justification of values. I'm going to squish it over from the left, or I'm going to squish it from the right to give it to be a certain width of information. Remember, you can also use LPAD and RPAD to trim the values down, because if you pass it a smaller size, it squishes it. The trim commands of ltrim, rtrim, and trim can either take out just default values of spaces, or you can take out specific patterns that you see on either the left or the right side. So just an FYI, that's what the trimming commands can do. I want to get part of a string. Oh, substr. Ah, that looks a lot like substring. Oh, that's because it is. And then if you want to manipulate the string, a little bit different from simply just a partial string, we have concat, replace, upper, lower, and init cap. So you can do some basic string manipulations as well. Some examples we see for this, we have a substr examples where I have substr first name, comma 2 as partial first. So I'm going to go to the second letter and then go to the end of that, so like there. Substr last name, comma length of last name divided by 2. I'm going to get the last half of the last name because I'm passing it the halfway point of the string and going from there into it. And then substr first name -4, I'm going to go backwards 4 spots. So unlike in Java land, when you can pass it negative numbers, and it starts at the end of the string and works its way back towards the front. Pretty cool on that. You can see some manipulation right here of upper, lower, and substr on the next section. And so I have lower city, and then I'm using the concatenation operator of Oracle with the pipe key, and then how I'm grouping that together with, in this case, a space. I have my upper modified by as big mod, and then substr city 4 as a partial city name. And in this one, I'm also using a numeric function of mod zip2 to only get the even numbered locations. We have no more seeing examples. We have LPAD and trimming. So with LPAD, we have city, 50, and asterisk. We're going to pad it from the left and fill it with asterisk, so it's 50 spaces big. On RPAD city 6, I'm going to take only 6 characters, which if it's so if it's more than 6, I'm just going to chop it all off. But if it's less than 6, everything up to the 6th space will be filled with a question mark. And then RPAD city 20 question mark will be doing the same thing, but up to 20 characters this time. And so anything that's bigger than 20 will get chopped, but anything less than 20 will get padded with questions from the right-hand edge. And this is only for zips greater than 5,000, less than 5,000. On the trimming side, we have ltrim cody C, which will give me, from Cody, I get OD, because I take the CF off the left side. On my rtrim xxxyy space capital Z, then I'm taking xy from the right. I'm not going to take anything off because the xy is not on the right side, so I won't chop anything. On rtrim xxxyy with a lowercase z, I'm going to take the z off, so it's just ended with a y. On my ltrim Cody with no second parameter, just going to chop off the spaces from the left, so I just get Cody. And then ltrim xxxyyyx, I'm going to trim off all the x's because every x matches that, so I just get 3 y's in a rear, and that's going to be using the dual table on that as well. Numeric functions only work in numeric types. I know, it's crazy. So we have the idea of abs for absolute value, so standard like that. So again, if you're using that lovely V shape by pointing to your own abs, you get the abs value with that. Mods for the modulo, usually you see this with a % on Java land or Swift, but in Squirrel land, we use the mod command to make that happen. Round, passing in a value and an optional precision, and trunk, passing a value and optional precision value, so we can either do a rounding or a truncation of the existing data. And then floor and ceiling values, so we can get the top value with the ceiling or the bottom value of the end for the floor. We can see round right here, we have 1234.1272. So it's going to go over to the right-hand side of the decimal point and round it to 1234.13. And I have round 1274.127 -2. It's going to go on the left-hand side of the decimal. I'm going to get 1300. So it's really pretty cool on that. So if you pass it a negative number, it's going to the left of the decimal. If it's a positive number, it's going on the right-hand side of the decimal. We also have arithmetic. It's not quite a function, but it works the same kind of approach. We're going to do manipulation of numbers. And it works just like it does in regular math land. So we have PEMDAS, parens, multiplication, divide, add and subtract to make sure we have that happening. So PMDS, we don't have the exponentiation in there because exponentiation will be handled in a different fashion, aka using powers. Oh, I know because it uses a function. And then we have the case statement. So a case statement isn't quite a function, but it goes in the same basic approach. It's how we process information. And so we're going to handle multiple options in Squirrel land. It's like an if-else or an if-else-else-if block. And the order of evaluation of those things matter, so you make sure you organize the structure of your case statements so you don't accidentally exclude a value from being processed. And it goes case and then when, the field you're working with, the comparison you're doing, then as the next keyword and the value you're attaching to it. The next and any further whens are all optional. That's why it's italicized right here. You can also have a default else for the default case. And then end, and then again, because Henriksen's I am so picky, as whatever named column. So case, when, field, the comparison you're doing, the then, and then the value. And you want to make sure that all the value types you're doing, whatever you're doing for the default and any then that's on there, they have to have the same type of data. You can't have, oh, this one's an int, this one's a string, this one's a card. No. They all have to be the same type. So keep that in mind. We have a case example right here. So we're selecting first name in case when zip is less than 1,000. It's going to be here. When zip is less than 399, it's going to be there. And so 2,999 is less than that. So if I put 0, that's less than 1,000, it gets here. It won't then hit the when because of less than 39.99 because I've already processed that value. So it's only if it goes to the next step would it even actually retrieve that, just like a regular if-else in Java line. Once it's gone inside a when, it doesn't go to any subsequent whens. And then I have my when zip is greater than 4,000 over there-ish. And if somehow I get something that's doesn't fit that pattern, I don't know how because it wouldn't actually exclude, I don't know. And that as where are they? So I can use the idea of a case example to make sure that happens and go from there. We also will be handling null values. There's the built-in OK version of NVL. I really don't want you to use it, but you might see it in some of the examples. And so NVL, and pass it the field name, a comment, and then the value you're going to set apply instead. And again, because you're using a function, make sure you use the as command to name that out, and from table name. The preferred way I want you to do that is to use the case clause, and by using a case statement, you have the when field name is null, and then you pass it the appropriate value, and then when it's an actual tested value you want to actually work with, you give it a different value from that. Oh, I know, it's crazy. So we can handle null values in the same basic approach by working with that. And finally, we have the dual table. I want to get data without a table. This is a placeholder we use in Oracle-based databases. You don't have to worry about this if you're using MariaDB or MySQL, but it uses it to actually retrieve data from a select clause without actually working with a specific table. And that's what we do for the idea of that when we saw the examples earlier when we were talking about from dual, because I just want to retrieve the data from the actual select clause itself, and I'm not working with any data set beyond that. Hope this is helpful. Practice your using functions and queries. Have a good day. Cheers, and see you next time. Bye-bye.